Good morning, good afternoon, good evening, everyone. Thank you again for attending this webinar. Today we'll be talking about on-prem data centers and why with public cloud or clouds that would be a perfect match. Few things about myself. So I'm a principal solutions architect working for Mirantis for about 4 years now. I've always been in the space of open source. So I'm quite curious by nature, but I am open source by choice. I've been working in the Linux space since 2004, OpenStack for most of the project's life, and for the last 4 years, Kubernetes. In the previous webinar, we did discuss about why using only public cloud is not the right choice. I still am very fond of that meme, where we understand the pressure of sometime keeping one of the EC2 instances on and seeing the bill, because some of these instances are quite expensive. But as a summary of what we covered the last time, cost management is something which is definitely very key when using public clouds in general. And we did talk about when that tipping point would be, when you would need to move from that OPEX model to CAPEX model. So to be more in a predictive state of, instead of being pay as you use, but be more predictable, forecast, and then prepare your infrastructure for applications that do not that are made to run in the long run, right? We also covered some items around having less staff. I know that this is one of the arguments from the public cloud vendors, that you would need less staff. Don't think so. You still need to have expertise in networking. You still need to have expertise in storage and compute. So basically, you do need to have at least the same, if not more, staff to cover all these different technologies. If you're using AWS, Azure, and Google at the same time, this definitely means more skills to acquire, and continuously certify against their solution. Around cost, one of the typical issues is the data egress cost, and the data egress cost is also associated with lock-in. So this is why we discussed about needing to have a proper data governance and understanding what needs to be put in the public clouds and what needs to be put in your private data centers. Unfortunately, around all that concept of data egress also comes that complex pricing model, because it's not only about a virtual machine running somewhere or a service running somewhere, but it's all about the peripheral services that you're using, like load balancers, security groups, firewalls. All of this comes and add more price on top of your application. So this is where also the bill shock comes at the end of the month or the year. We discussed about the importance of margin for your organization in terms of market capitalization, and that's why you have companies like Apple or Dropbox that drastically reduce their footprint on public clouds so that they could improve their margin. So instead of giving away their margin to companies like AWS that has very, very high margins themselves, they decided to invest in their own data centers. So again, moving from that OPEX model to the CAPEX model, more predictable model, and thus reduce drastically or improve their margin so that they would improve their market capitalization. And finally, we discussed about the concept of the reversibility pillar and how open source was a way of guaranteeing zero lock-in, right? So today we'll continue on that thread, but I'm going to talk more about the solutions and the solutions with what are some of the options available from the open source community that you can use to build your own private cloud so that you can host your different applications. The last time we also discussed about Kubernetes as being the killer app, right? And what I meant by that is, and here I quoted one of the famous lines in The Lord of the Rings. You have Kubernetes, and Kubernetes that can then be deployed across multiple environments, right? So we would be using Kubernetes as a cloud operating system, and Kubernetes would then be hosted on GCP, AWS, Azure, private clouds with Nutanix, VMware, OpenStack private clouds, or bare metal environments, right? And you would be using that abstraction layer to be able to deploy your applications across all these different environments with the principle of developing once and deploying everywhere. So that's the basic concept behind using Kubernetes as that abstraction layer or cloud operating system that can then be used across all these environments, so that then you avoid getting locked in into any of these specific technologies, right? So instead of using specific APIs from Azure or AWS to host your services, you will be using standard open source APIs from Kubernetes so that you can host your applications. I just read that tweet, which also aligns with one of the things that I typically hear from our customers, is that, well, Kubernetes is complex, right? And what that means at the end of the day is that teams are spending a lot of time managing Kubernetes, managing the pipelines, managing the lifecycle of the clusters, updates, upgrades, adding nodes, removing nodes, writing scripts, making sure that the cluster is working properly, defining logging, monitoring, and alerting rules, defining any auditing rules, right? And this is done in the, well, the development teams are thus not able to develop their codes and applications, right? Because they are spending more time handling the lifecycle of these Kubernetes clusters. So this is a tweet from Kelsey and from Pete, who both are saying that, yes, unfortunately, many companies are spending way too much time managing Kubernetes instead of building their products, right? And this is why we as Mirantis, for the last 2 years now, we have defined the ZeroOps approach. So the ZeroOps approach is made to help companies go back into the path of developing their products and developing their code, instead of spending a lot of time or a massive amount of time handling Kubernetes clusters, which at the end of the day is not their core business, right? So we have that very simple phrase, which I do like. So you do the apps and we do the ops, which at the end of the day means that, yes, we will be handling all the operations around Kubernetes clusters. And when we say Kubernetes clusters, we mean it at scale, so across multiple environments, different technologies, different versions, and we have that capability to manage these different clusters, so that you are then able to do your development and onboard your applications on top of these clusters. Okay. And how we will do that is in that model of platform engineering. So we know that we moved from the legacy type of organization where you had application teams and infrastructure teams or operation teams. They were separated teams. Operations teams typically manage the infrastructure, whether it was development or production, and then application teams or developers were then developing, packaging, and then asked to deploy the applications on top of these infrastructure, right? And you have that very clear demarcation line. And for the reason of optimization and making both worlds come together, the concept of DevOps was created, where both developers and operations were asked to do both development and production tasks on these different environments. And this is where their conflicts came in, because some of the developers were complaining of doing too much operations, and some of the operation people were saying that they were doing too much development tasks. So now we move towards that platform engineering model, where again, we have that separation between developers and platform owners. So not operations, but platform owners. The platform owners are there to make sure that the platform, whether it is development, staging, pre-development, or pre-production, or production environments, are aligned with developer expectations. And developers can then concentrate to build proper applications and products for your organization, right? And in that movement, Mirantis, we apply the ZeroOps offering to the platform model. And how we do that? So this is a combination of products, which I will be describing during this webinar, to make your private cloud based on open source technologies. But this is also through other services that we provide around support. So this is what we also call customer success, professional services to assist in any integration, and then training to also help your team get better when handling everything around these open source projects that I'm going to describe, which are OpenStack and Kubernetes. So what do we have in this support model? We have two support models. One is called OpsCare, another one is called OpsCare Plus. And you can see that these are very similar, except that OpsCare Plus is a fully managed offering, while OpsCare is a co-pilot offering, where we would help your team to operate your different clusters, right? But it is a 24/7 type of support, follow the sun model across different regions of the world, where we would proactively engage with you, provide you reports so that you can share it with your teams. We have SLAs that we align with, and we are also a single point of contact when it comes to handling third-party integration, so that we make the experience of supporting these platforms as easy for you as possible, right? At the end of the day, these two support models, OpsCare Plus, in a more specific manner, is aiming at providing you the same experience as you have for a private cloud that you would have for a public cloud, which means on public clouds, you don't do the operations of the platform. You develop your application and you onboard your application. So you would be also getting that same user experience on private clouds by coming and logging on these environments and onboard your applications. And with Mirantis in the background, we will be making sure that the platform works properly for you. Okay. All right. And also in terms of pricing, then in terms of pricing, we have either per node or per core pricing model. So a very simple pricing model at the end of the day, and we would apply the one that is more optimized for your use case, right? So if the per core provides you a better TCO, then we will go with the per core model. If the per node provides you a better TCO, then we'll go with the per node model. So it is a simple and predictable subscription model. It's very different from other vendors like VMware or any other, a lot of other examples, where you would just stack in licenses because one, they are closed source solutions, and two, they do have very complex pricing model where you need to just stack up various services that you are using here, right? So here, at least in Mirantis, it's not like this. We have a very simple pricing model where we provide all features, existing features and future features of our roadmap, but again, through a very simple subscription model for open source solutions. So now that we've talked about the ZeroOps approach and what we are getting with the ZeroOps approach, so what we mean by ZeroOps, what we mean by the support behind ZeroOps, and how we would provide it with an improved pricing to increase or to optimize the TCO, right? We will start to look at the concept of landing zones, right? So as we said, it's a combination between public clouds and your private cloud. On public clouds, you have the concept of landing zone. So on private clouds, you will also have the concept of landing zones, right? So here we'll start to look at the landing zones for Kubernetes as a service. So how that will look like is here, this is an example where I'm using Terraform, okay? So infrastructure as code to define the deployment of my Kubernetes cluster. And what I'm doing here with Terraform is that I'm building a Kubernetes cluster. which contains a Mirantis container runtime. So this is the Docker engine. You have on top of that a fully standard Kubernetes distribution, which is called Mirantis Kubernetes Engine, right? And we also deploy through the Terraform scripts the Mirantis Secure Registry, which is an image registry. Okay, through Lens Autopilot, which is a DevOps as a service offering that we also provide, we have the capability to deploy extra services on top of the Kubernetes cluster to do any extra integrations. Like, for example, we would be able to deploy various CI/CD tooling, like Argo CD or Flux CD. We would be able to deploy multiple networking tooling, like, for example, Istio for Service Mesh. We would be able to deploy various security tooling, like Falco, for example, if I want to monitor events. And I can also deploy logging, monitoring, and alerting toolings so that I am able to monitor the states or the different states of my Kubernetes cluster, right? So this is a very simple design, right, which is repeatable. And here I'm just providing a KPI, which is you would be moving from design to run in less than 1 hour. Obviously, if the infrastructure is smaller, right, like, for example, a couple of worker nodes, then this will not be 1 hour. Will be way less than 1 hour, right? So I'm just giving an extreme number here where we have a large cluster that we are deploying with that given scale. So, right, in a conservative, as a conservative number, I'm giving this figure. But if you have a couple of nodes, then this is a couple of minutes, which is used from Terraform to create the infrastructure and deploy the different services. Okay. Through this Terraform, obviously, we can then also add extra nodes. We can remove the nodes. We can update the version of the cluster. So we have onboarded in Terraform not only the modules to manage the underlying infrastructure, but also the provider, which knows how to manage Mirantis Kubernetes Engine and also Mirantis Secure Registry, right? And we have published all this to the HashiCorp repositories. Once we have that landing zone, this is where we are able to deploy the what we call the secure supply chain. Okay, and how the secure supply chain works then is we would be combining the features of Mirantis Container Runtime, which is the Docker runtime, the Mirantis Kubernetes Engine, which runs the workloads, and Mirantis Secure Registry, which is the image registry, to build what we call the secure supply chain. And what that means is the developer will start to create the code, push the code, right? Integrate that with CI/CD so that the code is built into a Docker image. That Docker image can then be signed, okay? Once the image is signed, we then push that image into the registry. When it gets into the registry, then the registry will have some rules that we can define so that you can verify the signature of the image, scan the image for any known CVEs, right? And based on the results of the signature check and the scanning of the images, we can promote that image from a given, let's say, pre-deployment or pre-production repository into a production repository, right? Once the image is in a production repository and ready to be run in the Kubernetes cluster for production, right? We can also enforce in the Kubernetes cluster the verification of the image signature and make sure that we only run signed images. So this is what typically we call the secure supply chain, where on one side, the developer will be signing the image. The developer will make sure that the image that is put into the registry has the proper signature, has the proper security posture in terms of known CVEs. And then once this is promoted to the proper repository, the platform engineer will make sure that the application is running properly in the Kubernetes cluster with the right level of security checks, right? So we talked about Kubernetes, and you can also say that, yeah, in the context of multi-cloud or hybrid cloud, you do not only use containers in these public clouds, right? So definitely then you can also build or complement that Kubernetes as a service offering with a true private cloud experience based again on open source technologies, right? So Kubernetes as the container solution, open source container solution for to manage or orchestrate these your containerized applications. And then we as Mirantis, we provide the concept of Loki, so Linux, OpenStack, and Kubernetes infrastructure, right, to build that true private cloud experience. So again, we have that concept of landing zone, and you can see that the design is also very simple, where you will have Mirantis OpenStack, which will be deployed so that you can then host the Kubernetes as a service offering. So Mirantis Kubernetes Engine, Mirantis Container Runtime, and Mirantis Secure Registry that can be hosted on top of Mirantis OpenStack for Kubernetes. But Mirantis OpenStack for Kubernetes will not only provide the capability to manage virtual machines, but will also provide the capability to do network, software-defined networking, and software-defined storage, right? So this is a full and complete private cloud running in your data centers or in a colocation site. And you will have very similar core components as any other IaaS offerings, okay? So this is made to run in less than 2 weeks. And when I mean here less than 2 weeks, I mean that you get the hardware, you install you install the hardware in the proper racks. And once this is done, then we power on the servers, we install the operating system, we deploy everything. And after 2 weeks, typically, you have your cluster up and running, worst case, right? We can also automate that and make sure that we can go even faster on vetted hardware, where we have certified the solution on that hardware, and we make sure that everything is properly configured, so we can reduce that number and make sure that you get that private cloud experience in a reduced time. But here again, in a very conservative way, I'm just giving 2 weeks. This is some of the service that you will get out of the box. So this is a self-service offering. So this is why we call it a true private cloud offering, where you have the capability through a web UI, through APIs, to manage compute services, storage services, networking services, bare metal lifecycle management services, and various other services like IAM, so identity and access management, image repositories, secret management, load balancing, etc., right? So you have a lot of features that are made available through OpenStack, and this is the perfect platform to run your Kubernetes clusters in your private environment, right? So again, the concept of Loki with that full open source experience, Linux, OpenStack, and Kubernetes infrastructure. So if we are to look at the Kubernetes cluster, I'm going to log in into the system. Here I'm using the admin tab. Once I log in the admin tab, I would have admin account. I would have the concept of multi-tenancy. So this is what we call the project. And here you can see that we have multiple projects. So you have very hard multi-tenancy in OpenStack, so that you can dedicate specific projects or tenant to specific users, and they will only have access to the resources within that tenant and will not have any access to other resources in other tenants, right? So you have that hard tenancy concept. And once you are in your project, then you can manage compute resources like virtual machines, images, key pairs, server groups, right? So you can manage your different instances. So to create an instance, basically, you click on instances. And then once you click on instances, you will basically launch your instance, right? And here you have some parameters to pass, like the name of your instance, the source image, right, that you're using, the flavor that you're using, the networks that you will be using, etc., right? You can obviously, everything that I'm doing here, you can do that through APIs. So in Terraform, you have OpenStack modules, and you can create all your different resources using OpenStack, and you can then define very complex setups within the OpenStack solution, right? So here again, the experience is around ZeroOps. So we put in place that infrastructure, we manage it for you, and then you can log in into your specific tenants and deploy your applications and get the value out of the platform, right? So we reduce the overhead of being able to manage that cluster. We do it, and then you consume the resources of that cluster, right? So what I did for compute, you can also do it for storage, where you can manage the volumes, define backups, or create your backups, snapshots. You will be able also to do it for networking here, out of the box. OpenStack supports both underlay and overlay networks. So you can create bare networks, VLAN-based networks, GRE networks, GNV networks, VXLAN networks, right? So you can define various underlays and overlays. You will be able to define your own private routers, expose them externally, define your floating IPs so that your virtual machines are exposed externally, define network quality of service policies, define your load balancers if you want to do highly available workloads. And all of this is, again, self-service and out of the box with a very simple pricing model from Mirantis, which is node-based, right? So all these features are made available, and we don't price per service. For example, micro-segmentation is included out of the box in Mirantis solution, where you would have the ability to manage streams in between virtual machines, not only at the port level, but also at the application level, right? DNS as a service can be managed, and you also have volumes, so block storage, object storage. So if you want to have an S3 compatible object storage, this is also provided out of the box in Mirantis OpenStack. And you also have file system as a service with Manila component, right? So here I discussed about the Kubernetes as a service landing zone. And then, as I said, if you want to complement the offering with a true private cloud offering, we as Mirantis, we can also offer Loki, which is Linux OpenStack Kubernetes infrastructure. But we did say that Kubernetes is the cloud operating system, right? So why am I talking about OpenStack, or why am I talking about the virtual machines? Again, here, the idea was to show you that with that OpenStack cluster, you can host in a very efficient manner or in a very cost-effective manner your different Kubernetes clusters, whether it is for staging purposes, whether it is for development purposes, or whether it is for production purposes, right? But there are companies that today are running quite massive or need to run massive migration projects. They need to migrate from, let's say, VMware, right, virtual machines, into a new platform. And as I said, Kubernetes is that cloud operating system, or that abstraction layer, right? So this is the perfect fit, or this is the perfect destination to move your VMware virtual machines into these containers, right? How do we do that? We do that through something we call AMMP, so Application Modernization and Migration Platform, right? So this is a product that Mirantis provides that can help to increase the speed of migrating virtualized applications. So let's say, for example, in VMware or Nutanix or in bare metal servers, right? So you move them from that legacy world, which is costing you a lot, and move them into Kubernetes. That Kubernetes cluster can then run in a TCO optimized platform running on OpenStack, or running in other environments, which may be in the public cloud environments, right? So again, we are in that multi-cloud or hybrid cloud environment. So you move from that costly platform and you move them into TC optimized platforms. This is an example of some of the projects we ran. We had to move 700 applications. Before moving any applications, we need to do an assessment, and I'll go through the whole process, but we did an assessment that took us around 3 months to do the full assessment of the 700 applications. So this is quite reduced in terms of timing, but also in terms of human effort, because you can see here that in terms of speed, we went around 600% in terms of the amount of time we needed, or the amount of our capability to reduce the time to analyze or assess all these applications. Then it also means that we are saving a lot of human efforts, right? So we calculated that we saved around 20,000 plus human hours by doing that app assessment and then migration, right? Once we do the app assessment, we then start to containerize the applications, and in parallel, we build the landing zones, right? So we had multiple clusters to build, and then multiple applications to deploy in parallel, as we are containerizing the applications and building the infrastructure, right? So all in all, it took us around 12 months to migrate these 700 applications from VMware into something that didn't exist, right? So the landing zone was not there, or the different clusters in the landing zone was not there. The applications were not assessed, and the applications were not containerized. So in around 12 months, with reduced time, saving human hours, we were able to migrate these applications into Kubernetes, right? So how do we do that? We first need to do the assessment, right? So we need to analyze the workload, and we have something which is called X-ray. So once we have detected the workloads, we then go into these workloads, and then we do an X-ray of this application, right? So we don't install any agent in the virtual machines or in the physical servers. We only need to connect through SSH or remote management to Linux and Windows services, right, or workloads or virtual machines. We only need to connect to these virtual machines, and once we get or connect to these virtual machines or physical servers, we can then start to scan these different applications, right? So this is the process where we call it X-ray. Once we have finished that scanning of applications, we build what we call that intelligent recommendations, right? So in the intelligent recommendation, we will have the list of applications that we have scanned, and we would then be able to provide a ranking or give it a kind of note, right? We would then, through that ranking, say whether it is interesting to reinvest or to retain or retire that application, right? So this is a very simple way for decision makers to see the full picture of the application portfolio in the existing world, the VM world, running on VMware, Nutanix, or other physical servers. Just look at these applications and then make a decision of whether you need to reinvest into transforming them into containers or just keep them as virtual machines, right? So this is what the intelligent recommendation provides. Once we use that intelligent recommendations, we would then rationalize. And this is where we would decide, based on these recommendations, whether we just keep these applications or we decide to rehost or replatform these applications, right? If we are to rehost or replatform these applications, then what we will be doing, and that's everything is automated through the tool. We will then start to containerize these applications. So we build the Docker file, we look at the application, we create the Docker file for that given application. We look at all the dependencies that is required. So the base image required, the dependencies, all the libraries required, the configuration file required, the connect points towards, for example, databases and all that. So all of these are that has been actually identified during the assessment process is now used to build that Docker file. And once that Docker file is created, we then build the container, and push that towards a registry, right? Once this is in the registry, we can then create what we call the deployment blueprint. So the deployment blueprint will define how we need to deploy that application. So what are the properties of that, or what needs to be assigned for that application to run properly in Kubernetes. So how to handle secrets, how to handle the config map, how many replicas are required, what are the limits, the resource request and limits, how is the service exposed, or are any services authorized to be exposed externally, right? So all of this is defined in the blueprint. And once we have that blueprint, we now have the container image, which has been built and pushed towards a container registry, and the blueprint, which can then be used to pull the image and deploy it in a Kubernetes cluster, right? So we would then deploy that blueprint, test, and make sure that the application is working properly. If the application is not working as expected, then we reiterate, we rebuild the application based on the modifications we need to apply to the Docker file. Then we readapt the blueprint, and then we redeploy based on any of these modifications. We do that as many times as required until we have the application that is properly running, right? So this is how the app migration workflow works. It is as automated as it can be, right? So basically, we can automate all these different steps. The only thing that we would be doing is we would just stop the automation at some point just to make these decisions. So you have the report and you can make the call on I want to reinvest or not, right? So I want to put them into containers or not. And once this is decided, we can then define what we call waves and deploy the application into Kubernetes, right? So here, we pushed again the concept of, okay, we have a landing zone, Kubernetes. We know where we can run that Kubernetes cluster in a private cloud with OpenStack, and the concept of Loki, Linux, OpenStack, Kubernetes infrastructure. And now I can move my applications from the costly old world, from VMware, from bare metal servers, from Nutanix, and move them into Kubernetes. Okay, that Kubernetes can run in your private cloud, but again, as Kubernetes is that cloud operating system, you can also run them in the public cloud. Okay. The interesting point also about app migration, and we did talk about the reversibility pillar, for example, right? So as the application is now running in Kubernetes, with that tool, you can decide to redeploy that application in any of the environments, right? So this is where, in terms of deployment, you can deploy it in a public cloud. And at some point, if you see that the public cloud is too costly based on the application profile, you can reuse that deployment workflow to deploy that application based on the blueprint into a private cloud, right? So for us, this is very simple. You're just pointing to a new destination, a new Kubernetes destination, which is declared or defined in the tool, and you will be able to deploy that application into another cluster. Let's say at some point you decide to move back to another public cloud, then you can do that again. You move that application towards another public cloud, or vice versa. You can retrieve or you take back all the public cloud applications and you move them back into your private clouds, right? So again, in terms of reversibility here, you have Kubernetes, which is the cloud operating system, and you have the tooling to move applications around based on various decision points. So these are the supported use cases by the platform. So you can see that we have multiple operating systems that we do support. So we have Red Hat, CentOS, Ubuntu, Debian. So many of and I haven't listed everything here, but many of the major Linux operating system. You also see that we are supporting Windows 2008, 2012, 2016, 19, and 2022, right? Which I didn't put here, but we also support 2022 Windows version, and AIX also, right, for WebSphere applications. In terms of then framework, we would support all the major Java middleware frameworks. WebC, WebLogic, GBoss, Tomcat are supported. We would also support the various development stacks for Windows, so IIS servers, applications, .NET, .NET Core, Java applications, right? So we will also support these applications, these frameworks or applications running on these frameworks for Windows Server. And then we also support various stacks like C and C++ applications, Bash and shell scripts, Nginx, Golang, Node.js, Ruby, Drupal. All of these frameworks are then supported and can be scanned and migrated into containers, right? We would not touch the databases, so we would do that through specific tooling or services, right? So we don't include any of the data management or migration or database migration using application modernization platform, but this is done through external tooling. Sometimes the database technologies come with their own migration tooling, so we'll leverage that, but we don't do that automatically in the tool, right? We concentrate on the application code or the application part and not the data part. Now that we've seen the concept of landing zone for Kubernetes and why we need to do Kubernetes in private cloud, so that if we also use Kubernetes in public cloud, we have that cloud operating system. We also looked at where I can run my Kubernetes as a service in a true private cloud, self-service, API-driven, which is Linux running or OpenStack running on Linux, right? So the Loki platform or the Loki concept, Linux, OpenStack, Kubernetes infrastructure. Now that I've also seen how to migrate my applications or my legacy applications from VMware or Nutanix into Kubernetes, right? Why not also explore how I can do ZeroOps in a more extreme manner? And what I mean by this is, if I go back to the initial topic of complexity, which is many organizations are spending a lot of time managing Kubernetes and not doing enough development. Why not then, in that case, allow these organizations to only do development, and we do again that full operation of Kubernetes in a even more packaged way, right? And this is what we in Mirantis we provide through a platform which is named Amezi.io. So Amezi.io is based on an open source solution. So the open source project is called Lagoon, right? And how Lagoon works is that it allows you to rapidly deploy your applications and see the results in less than 4 hours, right? So take from an application towards production in less than 4 hours, without having to learn Kubernetes, without having to learn how to deploy Kubernetes and where to deploy Kubernetes, how to do CI/CD on top of Kubernetes, how to secure your applications on Kubernetes. So you don't need to do all that. The first time you will be doing that, it will take less than 1 hour, 4 hours, and then the other times it will take a couple of minutes just to update your code into that platform, right? So you have various steps like installing the Docker, the tooling in your workstation. You will be cloning your code. You will be integrating that code with the Amezi.io platform. And once you are ready, you will start to build the application and deploy that application, right? So you have these various steps from your code into a Kubernetes platform. So let's see how that works actually. So this is the Amezi.io an example of Amezi.io dashboard, right? So in the Amezi.io dashboard, you can see that I have multiple projects. So I'm going to use the project, this project, the Virassamy Node Simple, right? So this is a very simple Node.js application. And in that Node.js application, I have integrated it into Amezi.io, right? So here I have done that step of installing the Docker in my workstation, clone my code, and integrate it into the platform, right? So I'm at that given step, right? I haven't done the build of the application, the deployment of the application, and see the result yet, right? So all of this will be coming afterwards. All right. So you can see that it is integrated. It is connected to my GitHub repository. I'm filtering on these three branches: main, dev, and feature branch. Okay. I'm looking at the pull requests. And I don't have any of the development environment in use, right? So I'm only using the production environment. And when I click to that production environment, I can see that the environment is of type production. The branch that I'm monitoring or getting the source is the main branch, right? And I can also click on this to see the result of my given application, where you can see Mirantis rocks you. Okay. So let's say now I want to change that. Right. So you can see that this repository is connected to demo Virassamy node simple.git. So this is actually that repository, right? The demo Virassamy node simple.git. Okay. And what I will be doing here is I'm a coder. I don't have any experience in Kubernetes. I don't want to have that experience in Kubernetes. I just want to concentrate and build products and code and have that made available for my customers. I'm going to make a very simple change here. So have in here Mirantis rocks you, right? That phrase actually which appears here. And what I will be doing is I'm just going to copy, let's say, for example, easy into words. Now, if I check words, I will have Amazy rocks you. Okay. What I then need to do is now I need to add or commit that code. Okay. All right. So now I've committed my code and I just need to push it. So now let's see the result. So if I go to that project again, and I'm going to check the deployments, you will see here that there is a new deployment that has just been created. So this is my local time. It's almost 10 p.m. here. This is the date, right? You can see that the status is pending. I've just deployed it 13 seconds ago, right? And at some point, right, you can see that it is now moved from pending state into running state, and it will be closed in a couple of seconds, right? So let me just look at that project again. Go into the deployment. So this is complete, and this is still going, so running. And in a couple of seconds now, it will be done, right? You can see it is now complete. Okay. So we can then look at all the different steps that happened if I'm interested. So I can see what Lagoon did in the background. So it took my code and called the build command, check out the repository, look at the access to the registry, configure the variables, check the initial environment setup, build the image here. You can see all the different parameters passed and the Docker file used to build the image, roll out the tasks, etc., until I build and deploy the application, right? So if now I refresh my page, you will see that automatically now it is moved to amazy.io rocks you, right? So in a very, very simple manner, my coder did not have to take care of creating the cluster, managing the cluster, defining the resources required for the cluster. Do I need more nodes, less nodes? What are the properties of these nodes? How many CPUs and memory I need to attach or provide to that node? How did I secure my cluster? What is the version of the cluster? What image I need to build? containers, what are the artifacts I need to build to run my applications on Kubernetes. All of this was completely abstracted from the developer experience, right? The developer is now concentrating on developing his or her application, right? And do GitOps, push the code, and in the background, Amizi.io with the Lagoon open source project is going to build and run everything into a given production grade cluster. So here I did step 4, 5, 6, and 7. It didn't take 4 hours simply because in that case, everything was already built. So as you will be then iterating into your newer versions of code, you will do that in a couple of seconds, couple of minutes from your build into going into production. So that's how, in terms of outcomes, you're getting faster. We can see with our customers, when they are using that concept and applying these concepts, they are definitely going very, very fast because it's just push your code. Develop, push your code, and we take care of everything. We also take care of managing the security, as I said, right? You don't need to understand, if you don't want to, what are the security capabilities you need to apply to the base image. What are the security that you will need to apply to the Kubernetes cluster? We take care of that, right? So you will have fewer CVEs in production because we continuously in the background curate the base images and core components. Okay, and then it's 99.99% of application availability because we spread the workloads into multiple replicas across multiple data centers. Okay, so you have very high SLAs in terms of application availability. This is, in a nutshell, how that looks like. You have all the different components and all these different services that we provide around Amizi.io. It's not only about deployment of applications and release management, but it's also about handling all the rest of the things for you in Kubernetes, handling the persistent volumes, handling the auto-scaling, handling the observability, managing the alerts, managing the infrastructure, managing the load balancers, packaging the code, guaranteeing security, doing the governance and compliance, 24/7 support and maintenance of the platform. And obviously you have access to a chat support, which is provided here, right? So you can directly talk to us, log in and talk to us, and we'll provide support to help you deploy your applications even faster, right? So this is our main KPI. You concentrate on your code, you deploy your applications, and we take care of everything else. What is important to understand here is that these are the supported technologies and frameworks. Today, we would be supporting Drupal, WordPress, Symfony, Laravel, Gatsby, Silverstripe, .NET, React, Python, Node.js, Django, Matomo, PHP, Hugo, Wagtail, Opino, Prismic, and we are adding more into the technological stack, right? So we are currently building or are in the process of adding more frameworks within this stack in terms of supportability, right? So we are creating all these base images and core components so that when you're building your code that would run in one of these frameworks, again, you have that concept and principle of you build your code, and then we move that into the proper curated images, and you run that into the platform. And under the hood, then we have all these different environments that we support. It is a hybrid cloud environment, so we have on-prem and private clouds that we will be supporting with OpenStack, for example. But we will also be supporting on-premise Kubernetes clusters running on VMware, OpenShift, Nutanix, and also public clouds running on AWS China, Alibaba, Google Cloud, and Azure, right? So this is a very rich platform offering. And on top of that, we support multiple Kubernetes distributions. And then we have built all the required tooling to do as all the different features that I explained, the scaling, infrastructure management, observability, et cetera, et cetera. Okay. These are the different offerings that we have, and this is how we can apply ZeroOps by Amizi.io and by Mirantis. But at the end of the day, what is important to understand for you is that typically organizations or application owners will only take care of that part, right? So your code and data, and under the hood, then you will always have an offering where Mirantis will be providing ZeroOps support, whether it is through the Amazee.io cloud, right? And in that case, Amazee.io manages everything, or through a dedicated cloud where you as a customer, we provide your own dedicated VPC, for example, or your cloud instance. And in that case, we would be able to apply ZeroOps also on that platform, but we would be doing the ZeroOps with the rest of the stack also. Lagoon as a service is where you come in also with your own Kubernetes cluster. So in that case, we have the ability to do ZeroOps from Mirantis different offerings on the Kubernetes cluster, and Amazee.io will continue to do the ZeroOps on the support of Lagoon and the given framework. And then we have the do-it-yourself, where in that case you provide your own environment, your own Kubernetes cluster. You want us to deploy Lagoon.sh into the Kubernetes cluster, and then manage the different frameworks for you. And we can do that in a ZeroOps approach, right? Which is different to what Amazee.io platform does. But in all cases, for all these different offerings, you are here. So you do the application code and manage your data. This is your primary job. And we do the rest to simplify the user experience. Okay. And here, this is a description of the cost optimization you can do when going into the route of Amazee.io. On the conventional operations, you need to do, if you're not doing ZeroOps with Mirantis, you need to continue to do the platform operations. You need to do the application operations. You need to manage all the different toolings, right? And this is what Kelsey was saying. Kubernetes operations, CI/CD operations, and all that is taking more and more time, and you are spending less time doing the applications and thus application operations, right? And with Amazee.io, then in that case, you don't do all this. You are spending a lot of time doing your code, right? So out of all, we are observing a 50% reduction of cost when you are able to concentrate on your cost, and we manage everything on our platform. We can run in different regions. So this is an example of our current regions we support across the world. And we have the ability to extend that and add more regions, whether it is on AWS, whether it is on Azure, whether it is on all the other environments that I showed earlier. We have that capability to deploy in these different regions so that your application is highly available, but also resilient across multiple geos of the world. Right? We would definitely also leverage CDN technologies, right? In that case, in terms of latency and being as close as possible to your customers, we would leverage the CDN network of these different providers so that your users also get a proper user experience. I know that we are a little bit over time. What I did cover today is the various options you would have to go into the mode of multi-cloud, right? So how to move from that application source world coming from Nutanix, VMware, Red Hat, Hyper-V, right? Bare metal solutions, how we can move towards something modern, open source based with zero locked in, and have that Kubernetes operating system so that you can move applications across your different platforms that you are managing. One of the destination could be OpenStack. One other destination could be to have OpenStack with Kubernetes for these modern applications, right? So here OpenStack only for some applications that you want to retain as virtual machines, but you still want to reduce the cost from moving from a proprietary solution towards an open source solution. So reduce TCO. But definitely if you want to have a Kubernetes story around a hybrid cloud environment, whether it is Google Cloud, AWS Cloud, Azure Cloud, and then on-prem private clouds with OpenStack and Kubernetes, then we as Mirantis, we have the various options to help you to build that multi-cloud environment with pure open source products, OpenStack, Kubernetes, application modernization and migration platform, which allows you to move applications from one side to the other, and the full ZeroOps experience with Amazee.io, where here you only concentrate on code and you don't need to care about everything else, right? Again, whether it runs on private cloud or public cloud. So thank you very much for your time. If you do have some questions afterwards, do not hesitate to reach out. Again, we'll be providing you with the links towards the video and the presentation. And if you want to learn more about Mirantis, feel free to go on our website where we have described all our different offerings and solutions. And we'll be happy also to have further chats with you to go into deeper details about our different products and solutions so that we can help you build that multi-cloud strategy. Thank you very much and have a great rest of your day, afternoon, or evening.